Hello everyone, I am Vineet Kumar Sinha from ABES Engineering College, Ghaziabad. In this video lecture series, we'll be discussing the subject Materials Engineering, and as per the uh, course recommended for B.Tech Mechanical Engineering students in AKTU syllabus. So this is the course description of this Material Engineering course, what would we see in our subsequent videos. So the unit 1 is having a discussion on crystal structure and also the mechanical properties and measurement. So crystal structure, the structured way of the topic-wise discussion would be on metallic crystal structure. Basically, what is crystal structure and how can we define it? Crystalline, what is crystalline material? What is amorphous material? Unit cells and lattice. Then metallic crystal structures. How many types of metallic crystal structures are there? Then imperfection or defects in solids, the point defects, solid point defects, linear defects, the surface defects, defects, interfacial defects, and also volume defects. That is various dislocation and strengthening mechanisms, the slip system, slipping mechanism, mechanical properties and measurement, different types of mechanical properties and what are their measurement techniques, the tensile test, compressive test, the shear test, and then we'll discuss the hardness, Rockwell, Brinell, and Vickers hardness in this unit. Unit 2 will, the Unit 1 will be covered in my subsequent videos. This will be covered by me only in my videos. I'll discuss all the topics of Unit 1. Unit 2 is having the topics alloys and solid solutions. What are alloys? What are solid solutions? Difference between alloys and solid solutions. Interpretation of binary phase diagrams. What exactly phase diagrams are, the components and terms associated with it. We'll go through it. And interpretation of binary phase diagrams, especially the isomorphous systems and also the eutectic systems like lead or lead tin system. And then we'll have the microstructure development of those eutectic systems also, and having a discussion on iron and iron carbide phase diagram. What are the phases involved in it? What are the salient features of iron carbide phase diagram? And also the microstructural aspects of all the phases involved, like alpha ferrite or delta ferrite, gamma austenite, cementite, and also the pearlite and ledeborite. Similarly, cast iron and high-speed steel will also be discussed in this unit. This unit will also be covered by me only in my later videos, uh, and I'll cover in those topics one by one. Unit 3 is having metal alloys. Here we get to know the alloying of steels and the cast iron and types of cast irons, the copper and aluminium alloys, the titanium nickel-based superalloys, and also the composite materials. This unit with the entire alloys and materials, so composites and titanium nickel metallic alloys will be discussed by my colleague Dr. Kaushalendra Pandey in his subsequent videos. Unit 4 consists of heat treatment of steel. Here we'll have to learn annealing, tempering, normalizing, various heat treatment methods, isothermal transformation diagrams, the continuous cooling curves, interpretation of final microstructure, case hardening, etc. This will be covered by another colleague of mine, that is Mr. Manabendra Saha, in his subsequent videos. The last unit, that is Unit 5, is based on non-destructive testing, creep and failures and non-destructive testing. So the topics covered under this would be creeps and failures, the mechanism of creep and the factors affecting it, introduction to non-destructive testing, what are non-destructive testing, how is it different from destructive tests, and what are the common destructive, non-destructive testing methods like visual testing, or liquid penetrant testing, magnetic particle inspection, ultrasonic testings, radiography, eddy current testing, acoustic emission testing, X-ray diffraction, and etc. Also, will have a discussion on properties of material or the behavior or properties of material at very low temperature, that is of the cryogenic range, minus 150 degrees Celsius, and also very high temperature. What are the factors affecting? What are the conditions affecting? And what is the material selection criteria for a matter or for a material having application of the very low temperature range and very high temperature range. So this will also be covered by me only in my latter videos. Uh, I will discuss one by one on every topic. Thank you.